Where do I say that? There we go. Okay. So today we are going to give a little intro refresher to R. I'll be going through some stuff on R. If you want to follow along, that's great. If you don't, you just want to sit back and get kind of like the overall broad stroke of it, that's great too. Either way, I will have this up on D2L, so you should be able to go back and go through it again. Because of that, I'm going to go at a fairly decent clip through this and cover a fairly large number of topics. If you're overwhelmed at this moment, don't worry too much. Please go back over the video once it's posted. That should be posted shortly after class, and go through it several more times. R is going to be one of the platforms that we're using extensively throughout this class, so I'm going to kind of go over some basics of how to interact with it, how to work with it, some things like that. One thing I do want to say, however, before we get going on that, is talk a little bit about the assessments which are going up. They are up. The first one is up right now. So what's going to happen is, as there is an assessment that relates to a lecture that we have or that we go through, I will post that assessment up on D2L. So for instance, the Intro to R assessments are up there at this moment. There is also a Dropbox for those. And again, there's no due date on this. I mean, like, technically, I wouldn't suggest it, but technically you could hand these in at the final and you would be okay as long as you did them sufficiently. I would at least suggest, if you're having a little bit of trouble with this, to wait until after lab, because there will be more things in lab that'll help you get through these assessments as well. So don't worry too much about that. A couple things first off. So there is going to be both a theory and an applied. If we go ahead and go into here, applied, intro, there are two different things in here. We have actually a PDF file, and essentially all it has is a list of questions in here. And all these are pretty short because most of them just ask you for a line of code and the result of that code. And most of this we'll go through as we go through here. And then you'll just type this into like a Word document or something, and then there is a drop box for both of those to dump those into. And coming back to here, there's one other thing. There is a file that you need to get to go through this. Essentially, all of these commands that you're going to come up with and put into there are going to be manipulations of a file. And if you come into files here, there is one for each of you. There is a different one for each of you. You all have your own individualized file that's different. One thing I will note, these are random generated files that have randomly generated names in them. These random generated names were taken from the 300 most common male names, the 300 most common female names, and the 300 most common last names in the United States. If they actually line up to your name, someone you know's name, anyone else's name that you possibly can think of, that's purely coincidence. I did not go through and see people's names into here. So, yeah, after I made them, I actually kind of figured out, hey, maybe this wasn't the best thing to do. Like, oh no. I won't download it now and show you. I second guessed myself because actually the data that became really easy to come up with is like weights, heights, BMIs, other things like that. And then I decided, oh wait, I'm putting like random names in there. What if they accidentally like line up with someone actual person's name? That's some way crazy BMI on there for. So if that actually happens, I did not mean for that to happen. There's lots of random generated stuff in there. So okay. So you each have your own individualized file that you'll be working with, so your answers, the code that you're using will be like very similar to anyone else's, but the actual results that you come up with are going to be different. One thing I will say is you're going through these assessments, feel free to collaborate, like to work together to help each other out, get through them, to use anything that you want. You can go onto the internet and try to look up how you do something or something else like that. That is how you will actually do this in real life. I don't want to artificially make how you approach these different than how you would actually approach this in real life. So go ahead, however you would try to solve these problems after this class, go ahead and do it there. Now that being said, you can't just copy someone else's paper because all your answers will be actually different than there. So there's that. But by all means, tackle it however you can go ahead and tackle it, whether that means asking someone else for some help on how you accomplish something, going onto the internet, something else like that. Any of those are A-okay. So again, there's one for the theory portion, there's one for the applied portion. The theory is kind of a little bit scanter for this because there's not that much in this case. And that Dropbox. Are there any questions on those assessments and how that works? Yes, Ryan.
Just to clarify, you have to divide up some theories behind classwork, and then the applied is lab work?
Well, it's not that clean of distinction. A lot of the things that are in the applied we'll actually go over today in class, like how to do those things. Like some of the theory will be in lab, but then lab is more designed to actually get you practice doing those things.
We do those specific things in lab, is that?
Yes, most of those specific things you will be doing lab. There might be a little bit in there one place or another that will actually extend you a little bit, but not much. I mean, it'll be small extensions, if anything, but not much. Okay. Any other questions on that? One other thing I will say, if you go to content, if I'm going to use files during the lecture portion, I will also have them in here as well under lecture files. So there's one small data file that I'm going to use that is in here. I put it up in there as well. So if you were following along as I'm going through class and you want the files I'm using, they're up there as well. Okay. Okay, so let's talk a little bit about what in the world R is in the first place and why we should use it and why do we even care. So first off, specifically, R is an object-oriented statistical programming language, and it's a statistical programming language in particular because there's all these preset functions that mostly handle statistical operations. So it's really nice because just in the base language, there is preset functions that do t-tests and chi-squares and correlations and all these other things that you actually don't have to go through and program in yourself. There's preset language to accomplish those functions. And so it's really designed to be a statistical programming language. Other than that, it's very similar to a lot of other, or in the syntax, somewhat similar to a lot of other object-oriented programming languages. So you don't, if you have some familiarity with those, a lot of things will sound somewhat familiar as we go through there. However, because it's a statistical programming language and not just like a statistical program, like SPSS or a lot of other things like Prism that people have used in the past in stats or something else like that, it has the flexibility and the power to essentially accomplish any task that you could really want it to do. You can design it to, or you could put in the code to actually make it solve whatever you really want. So it has this incredible amount of flexibility to it. Also, again, it's free and open source, which is great. Now, one of the things that's really nice about the open source aspect of this that you might not think about right off the top of your head is that this also means that is most of the time when people are using R and they actually develop a new computational system or a new statistical approach or some new way to analyze data and they're using R, they will actually release that code for R and you can go out, you can grab it and you can do the exact same calculations that people are doing with their publications on your own data if you want. So this makes it really, really nice. And a lot of people using R are very, my experience has been that they are very willing to let you borrow their code. Even if they don't publicly release it, if they say they're using R in like a publication, if you email them, just like getting their paper, you can generally get their R code as well. Like, can you give me your R code that you use to accomplish this? And most people will happily give that to you. So that's really nice as well. And also, this is kind of becoming the go-to statistical platform for most biologists, computational biologists, other things like this. A lot of data scientists are also moving heavily into R, although in data science it's kind of equally spaced out between Python and R. But for the biological sciences, it's mostly still R with some people using Python as well. So in this class, we will lean on R quite a bit. Now, R Studio is another thing that I had you guys grab, and R Studio is what's known as an IDE, or Integrated Development Environment. This is a kind of program that many programming languages have that essentially, to put it simply, sit on top of the programming language and give you this really nice program that allows more easy interaction with the programming language. has tools and other things in there that make it more convenient to do common functions and keep track of what you're doing and have code highlighting and all these other things that make it kind of nice to work with. And so RStudio specifically is one of these IDEs for R that make it a little bit more easy and convenient to work in R. When I first started working in R, I just opened up like, hold on, let me see if I can do this. Was R base? Yeah, this is what I started working in when I first started working with R, which is not fun. Like, you're just sitting here with this blank terminal, and it was the first programming language I learned, so I was just kind of like, yeah, that's not good. That's not the best way to do this. So don't do that. So RStudio provides you a much nicer landscape than that to work in, something that's a little bit easier. So for this class, we will be interacting with R through RStudio, which will make this quite a bit easier. Okay. Actually, let me go on to this instead. Let's talk about the basic layout of RStudio here. Okay, so this is kind of washed out. It's hard to see, but essentially you have 4 different windows when you open up RStudio. It may also look like this, where you have the console essentially taking up all of this, and then you have 2 windows up here. If you have that being the case, what you can do is you can go into File, New File, RScript. It'll bring up this upper left-hand corner file or window as well. So essentially you have these 4 different regions. You have the terminal down here in the lower left-hand corner. This is essentially that same terminal that I just brought up a few minutes ago in its own terminal. It's sitting down here in its own little place. You have the script window up here in the upper left-hand side. Now the script window, this is where you'll actually enter in the code. And so you'll type things up here, and then what you can do is you can highlight those things, hit Control Enter, and it sends them down to the console window here and actually enters them in. Now this is kind of nice because what this allows you to do now is write several lines of code. That's actually not code. That's just things. But imagine then you send them down, you get an error, and something's wrong up here. Instead of actually going through and having to retype the entire thing, you look over like, okay, what did I do wrong? Oh, I shouldn't have had a semicolon between this S and this L. Oops, I need to take that out, or I need to add one. So you go do that, and then you resend it to the terminal. This is the best way to be interacting with this. If you're trying to retype things every time, that gets really tedious. If you're trying to remember what you did, that's not very fun. Yeah, so that's not the most ideal way to do this. Again, we're going to be making what's known as objects in here. Like, actually, your data files are going to be in these things called objects, and we'll talk a little bit more about that as it goes on, but those are going to be displayed up here. So like, for instance, if I make something, like for instance, I want to make a variable that x equals pi. I get Control Enter, and then x comes up here. So now x is this object, and it's going to show up here in the upper right hand. So this is your workspace. You can toggle between your environment, which is your workspace, all your objects that you have, to your history. And your history then shows you all of the commands that you've entered in. When you first come into this is going to be not like that. It'll be less. Now, the lower right-hand corner, you have this window that has a whole bunch of different things. You can see the files. The files are whatever is in your working directory. We'll talk about that more in a minute. If you do a plot, it'll show up down here in the lower right-hand corner. For packages you have loaded up here, we'll talk about more in a minute. But the really big thing that you need to know about right now is the help. So if there's ever something that you were curious about or need to know how to do, you should take advantage of the help as much as you can. So you can type in here, I want to know how to get the mean of something. Oh, right here. This is how I do it. And you can come down, and it gives you the usage. We'll talk more about this in a little while, what that means, and how to actually go about getting the mean of some set number. So that's what we have down that window. So it's kind of the basic layout of RStudio. Okay, so let's talk a little bit about, so I want to start doing something. I want to start a project. How do I go about that? How do the files actually work in this? And let's talk a little bit about that. Actually, I need to go back to my... Okay. Go that slide? Thank you. Okay. So, first off, before I talk about this, I'm going to talk a little bit about working directory. Whenever you're working in R, there is a specific folder that essentially you're working in. And to find out what that is, there's a couple ways to do this. Let's go back to R. Down in the console, you can get WD, open parentheses, close parentheses. We can send that down to the console. So get working directory, and I'll read out the path that is your current working directory. This is where, if you're reading in files, this is the easiest place to read them in because all you need to give it is the actual file name or something like this. As you start every project, you should know where your working directory is. One way that you can set that is to go up to Session and set working directory, and then choose the directory, and then you can choose what file or what folder you want your working directory to be. As I begin, we'll come back to that in just a moment. So as you begin a new R project, the very first thing that you're going to make is the script file. This is essentially just a text file that is going to be up in the upper left-hand corner, the actual code that you're putting in that you're then going to pipe in down to the console is going to be in the script file. Now, there's a couple different ways to make that. The way that I make this, I usually do this, is I make a new folder for whatever project I'm going to be doing. So like random project. And then within this folder, I'm going to make a new document, random, and then you give it the ending of .r, capital R. So that is my new script file. And then what you want to do is set your computer so that by default, any .r files are opened by RStudio. So when you come in and double click on this file, what it'll do is it'll open that script file, it'll open up RStudio. The other automatic thing that does is it sets your working directory automatically then to the file or the folder in which you open this. So then you have your working directory already set. So let me go ahead and do that. Now, or actually, let me back out here. I've already done that in this other file in Lecture 2. I have my lecture2.r file right here that I've made, and then I just went ahead and opened up in there. On some operating systems or some ways that you have them opened up, it will not let you make an empty document, like a completely empty document file. So what you need to do is, in that case, instead of making the script file that way, you need to open up for the very first time, open up RStudio, go into File and New File, New R Script, and then once you have that, go into File, Save As, and then go ahead and save it into that file. So into, again, random project, and I could save random.r. Every time then after that you open that up, it'll just open up automatically in that folder. Is there any questions on that so far? Okay. So once you have that, and once you do that, you have a couple different things here. That's not what I wanted to open. There's a couple other files that are automatically created. Once you open up RStudio with a certain working directory, it's automatically going to create a .r data file and a .r history file. These two files, the .r data file has every bit of data that you entered into the workspace there will be saved in the .r data, and every bit of everything that you have, all the commands that you have entered are going to be into this .r history. So anytime that you now open up this script or this script.r file, and it finds also a .r data and a .r history in that same file, is automatically going to reload all of the data that you had loaded into the workspace, and then also the data that you had up into the history. Okay. Are there any questions with that up to that point? Okay. So again, to begin this out, create a folder, make a new R script file in that folder, and then you can place your data files into that folder as well, and it's going to be fairly easy to open them up after that point. Again, I've talked about this a little bit so far. When you're actually interacting with R, the best way to go about it then is then to enter commands into that script window, the upper left-hand window. Use Control-Enter to send those commands down to the console. Alternatively, if you don't want to hit Control-Enter, there's also, or for whatever reason it's not working, there's also a Run button up here in the upper right-hand corner. If you hit this little green arrow, it will send it down as well. It's the same as Control-Enter. Yeah, that's not what I want. Yeah, and then you can go ahead and if something doesn't go right the first time, you can edit your script in there and then resend it and do those sort of things. Okay. Let's talk about now the basic commands, or how R generally wants commands. So first off, R will take simple arithmetic operations. So like if you want to just enter in 2 plus 2 into the console, you will get an answer for 2 plus 2. It'll spit out 4. Or if you want to do 2 times 3, it will give you an answer for it. So if I want to just enter in, 2 plus 2 and send that down, hey, it tells me what the answer is. If I want to do 2 and then use star 3, this is basically the same syntax that you would use in something like Excel, but without the equals before. All of that works A-OK in R. More sophisticated commands then come into a specific syntax or form in R. And that common syntax for everything essentially has this. You have the command to begin out the line, and then within parentheses inside of there, you have arguments for that command. So argument 1 separated by a comma, then argument 2, argument 3, on however many arguments you need. Sometimes commands require 1 argument, sometimes 10 arguments, sometimes no arguments. You can actually sometimes have a command that needs no arguments at all. In that case, all you have is open parentheses, close parentheses. You still have to have the parentheses there, but you don't need to have any arguments inside of them. So let me show you how that works just a little bit. So for instance, like I did up here, we can do one command. You don't need to know this command. Save image doesn't need any, does not need any arguments with that. So I can just do open parentheses, close parentheses, and it just runs. It doesn't give you any output because there's nothing output, it just saved whatever we were doing. Okay. So some examples of this, you don't need to know exactly at this exact moment what this means, but for instance, one command is read.csv. This reads in CSV files. And we give it the first argument, file equals data.csv, comma, header equals t, which means it has headers. The C command. The C command actually means to combine these into one thing. We'll talk more about what that means in just a moment. But I can have C and then parentheses 1, 2, 3, 4. Those are my different arguments. Or then I can do the mean of 1, 2, 3, 4. Now I have to put it inside a combine as well, because inside mean, all of the numbers that you want to be a mean are one argument, so we have to combine them into one thing, or else it'll think 1 is one argument, 2 is another argument, 3 is another argument, 4 is another argument. So we have to combine those all into one thing with C. But if we wanted to get the mean of 1, 2, 3, 4, we could do mean in parentheses, and our first argument is C parentheses 1, 2, 3, 4. Okay, so let's talk a moment about making objects in R, or assigning objects. And there's two different commands for doing this. You could just use an equals, like for instance earlier I did x equals pi. That means that now x forever and after that in that till I remove it, x is going to stand in for pi. And we used to use either equals or dash greater than, making kind of like a little arrow. And there are arguments on both ways in which one is better. This was the original assignment operator. This is a newer assignment operator. I've noticed that people that have been using R for a long time really grumble at using the equals because it looks like a logical test. Like, does this equal that? We'll talk about those more in just a moment, but this is the one that I use. You can use either of them. So for instance, a couple of ways you can do this, x equals 3. That would mean that then forever and after there, x will be equal to 3. You could do y dash greater than 2, does the same thing, y will then be equal to 2. So let me show you how this kind of works. Delete all this. I can do x equals 3. Send that down. I can do y equals 5. So now up here in our environment we have x, and it tells us what it is. It's 3. Y, it's 5. So now what we can do is we can do y plus x. It will give us 8 because we've gone 3 plus 5. Or we can do y times x. These don't have to be single numbers though. We can do like a series of numbers. So for instance, instead of this, we could go c 1, 2, 3, 4, 5. Anytime that we want to combine several numbers together, we have to use c with the combine function. So we can do that. And what do you think if we do now y times x? What do you think that we get? Any guesses? What's that?
Would you get a new column or data set that was number 1, 2, 3, 4, 5, 5.
Yes. So we get 1 times 5, 5. 2 times 5, 10, 15, 20, 25. Okay, so that's the sign. We can make anything. We can use different names then, and I could call it name equals 34. You could just kind of do it however. Okay. Or again, we can use like data equals read CSV. Again, this is the command that we use to read in files, CSV files. And then we give it its name, data.csv. This is the file name that we're pulling from, and then header equals true. Again, we'll look at that more in just a moment. But let's talk about the different kinds of objects that we can have. So now we have these objects. What kind of objects can we have? And the most simple of these, other than just being a single number, is what's known as a vector. A vector is just a string of numbers together. And this is what we had when we talked a few moments ago, or what I showed you a few moments ago with x equals c 1, 2, 3, 4, 5. This is a vector. A vector that is 1, 2, 3, 4, 5. It's a string of numbers, and it therefore has one dimension. It has length. And it has a specific order. 1 is first, 2 is second, 3 is third, and so on. So these are the properties that we have with a vector. It also has a class. I'm going to talk a little bit more about classes in just a moment, but it could be a numeric vector. That's what, actually no, that's not what we had. We could have a numeric vector, which is just numbers, but generally not integers. We could have an integer vector. That's what we had. There's just integers, 1, 2, 3, 4, 5. We can have character vectors. Character vectors are just like, for instance, we have strings of letters, like your names would be character vectors. If I had all of your names together in a vector, that would be a character vector. And we also have factor vectors, which are a little bit weird. They look like a character vector in which they are names, but or something like usually spelled out, but they're actually bins, and they're then numbered bins. And so oftentimes what you have is a name that's repeated a lot of times. Like for instance, if I had a vector that had all of your genders in them, there would be a lot of repeats. I mean, some non-repeats, but a lot of repeating things. Or like for instance, your grade level. This is a vector. If I had undergraduate or graduate, it'd be graduate, 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 undergraduate, 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 undergraduate. So R would actually code those as ones or twos, but read out graduate or undergraduate. Those are a factor, essentially bins that repeat often that you can put things in. And they operate a little bit funky. We're not going to talk a lot about them right now. Later on we will. But so this vector can then have one of these classes. It could be numeric, it could be character, integer, factor. And as you probably imagine, some functions don't work with all of these. Like if we tried to take the mean of all of your names, you will confuse R. And then it will say, I don't know what to do with that. If we tried to say, take the mean of the factor that is all of your, like whether you're undergraduate or graduate, is also going to look at you and be like, I can't take a mean of a factor. And it'll give you an error. So if you're going to do a mean, it has to be numeric or integer or something similar to that. One thing I want to say is these are not the only classes in R. These are the most common ones, the ones that we'll be mostly using throughout this class. So a vector is just that. But let's talk about a different kind of thing. Now we can also have a matrix. Now a matrix is very similar to a vector, except it's in 2 dimensions. We now have rows and columns. And we can actually transfer between these. If we have a vector, we can make it into a matrix and vice versa. So for instance, let's go back to R. So we have this x up here. So we have x. And x is this vector of 4 different numbers. Or 5 different numbers, excuse me. Actually, let's make it 6 different numbers. By the way, you can always rerun this differently and it'll just change whatever object you have. What I can do is I could do x.matrix equals, and I could use as.matrix, which as.something usually changes one object form to another. So if I did as.vector, it changed it to a vector. If I do as.matrix, it'll change a vector to a matrix. I could do x. Actually, let's just run that by itself real fast and see what comes up. Okay, so the initial thing that it does is it turns it into a vector. So we have 2 dimensions, but one of our dimensions is just 1. So it has 1, 2, 3, 4, 5, 6 for one dimension, and it just has 1 for the other dimension. What I can do is I can change this, and I can change, okay, so I want the number of rows to be equal to 2. So now we'll get 2 rows. Wait, why'd you do that? End column. And so sometimes it doesn't work the way I think it should work. So I have to go back to as.matrix. And this is where you start using, oh, I just should, not as matrix, it's matrix. There we go. I shouldn't put the as on there. So what we get then is I can turn this into a matrix where I want the number of columns to be 2 instead of 1. So now I have 1, 2, 3, 4, 5, 6. So now I have essentially the same thing, a list of numbers, but we have them in 2 dimensions. We have rows, we have row 1, row 2, row 3, and we have columns, column 1, column 2. Yes?
Can you control which order it fills the matrix?
Yes, you can. And that's called the by row command in here. So I can go by row equals, oh, true. And so now it fills it the other way. 1, 2, 3, 4, 5, 6. So yes, you can change which way it fills. Again, right now, my point is not to give you all the specifics of these commands, but to give you essentially the nature of what a matrix is. So if you're not following all the specifics of this command, that's not important at the moment. We'll come back to that more in the lab as we go through. Okay. Also, an entire matrix will only have one class. It'll be a factor, it'll be numeric, it'll be integer. That was an integer matrix. They can only have one class. Okay, let's talk about another one. Another one, this is one that we will use a lot, is a data frame. Now when you pull up a data frame, it looks a lot like a matrix because it has two dimensions. It has columns and it has rows. The major difference between a data frame and a matrix is that a data frame is essentially a collection of individual vectors. And each column is its own vector. Now what this means now is in each matrix, the entire matrix has only one class. It can only be numeric. It can only be something else. In a data frame, every column, being its own vector, can have a different class. Now this is really nice because then what we can do is we can make something that has like, oh, I want column to be all of your names, and that's going to be character class. I want the next column to be all of your ages. I want that to be an integer class. And the next one, I want to have all the grades I planned on giving you randomly in this class, and that's going to be a numeric class, and so on like that. And so a data frame is slightly different. It's two-dimensional, but it's fundamentally different in this way that every single column is a vector. And each column can have its own class. Now this is the object type that's most analogous to a spreadsheet in Excel, and this is one of the object classes we're going to be using most often, or the object types that we're going to be most using in this class. Okay, so the next big thing is how in the world do you get data into R? The most basic that I've kind of been showing you so far is that you can get into there manually using like the assignment operator. So again, x equals c, and we have all these numbers, y equals c, all those numbers. Or you can read them in from a data file. And so here's one really good command to use is read.csv. Oftentimes we're going to be using CSV files. We'll talk more about those probably on Friday, what a CSV file is. But we can give it a name, use the assignment operator, and then use this command, read.csv, and then the first argument is the name of the file. As long as this is in your working directory, you can just give it the name. You don't have to give it the entire directory information. If it's outside, if it's somewhere else, like if you're grabbing it off the interwebs, if you're grabbing it somewhere off your computer, you have to give it the entire address of where you're getting it from. But if it's in your working directory, you just have to give it the name, and you have to put quotations around this. Otherwise, R is going to think you're looking for an object in the workspace, and it will just look for an object in the workspace. That's not going to work. And then normally, if you have headers, like the very first line of your CSV is like the column names, you add in there header equals T, which means header equals true. So, actually, let's do this real fast. I know I have if I go to Files, you can actually look at what you have in your working directory. And here I have this one that says biologists.csv. So I can go enter that in. So I'm going to say bio equals read.csv, and then I'll enter in the name inside quotation marks, biologists.csv, and then go outside the quotation marks, comma, header equals true. Control enter. And the only thing it does is just pops this up right here. You just see it. And as long as you don't get any red errors, hey, we're good, probably. And then if you look up here in the environment, we have it in the environment. And what it says is we have 600 observations of 7 variables. What this means is that the variables is essentially the columns that you have, and the observations is the number of rows that you have. So this is this. Now, that being said, it will tell you the matrix dimensions. If it's a matrix, it gives you observations and variables if it's a data frame. So this is a data frame. Another way that you can tell if it's a data frame is to come back in here and we go class, bio, and we enter that in. And in parentheses, do the bio inside of here. And it tells us down here it's a data frame. Okay, now in RCR, there's a couple ways. Now we can kind of look at this a little bit if we want to. We can come in here and click on bio, and it'll pull up in over your script window kind of just a spreadsheet looking thing of what your data is. So here we go. We have name, sex, age, hire date, residence, score, and then there's other things in there. Annual earnings. Okay, so we have this random stuff. Okay. Each one of these now is a vector in and of itself, and it's just this collection of vectors, and they're related across rows. So that is a good way using the read CSV function. And then when you open this up, this leaves tabs up here on the top that you can toggle back and forth between that data set and then also back to your script window. Okay. If you have multiple columns, R is going to try and make a data frame, and then when it pulls it in, it's going to do its best guess as to what class each of those should be. So for instance, if you have a lot of repeating things like the residence, I have all the different states in there, it'll just kind of say, okay, we have repeating character things, like Minnesota shows up several times, and this shows up several times. It's going to assume that's supposed to be a class or a factor, factor type. If we have all these numbers that are integers, it'll just assume that's supposed to be integer. If we have a bunch of numbers that have decimal places, it'll assume it should be numeric, and it'll just kind of fill them in. Sometimes it screws up. It does not always do that right, but it generally does it right most of the time. Okay, now once we have this up, what we can do is we can specify elements of the data. So for instance, if we have a vector, it has one dimension. So we only have to enter in one number to specify a specific element in a vector. So for instance, if we come back here, we have x, and x has these 6 different, actually let's make my matrix too. Let's actually get that entered in there. We have x that has these 6 different elements. If I want to pull out the 4th element here, how about the 6th element, just for the random, I put x, and then what we do is we put in brackets the number of the element that we want. So x bracket 6 gives us the 6th element, and that reads then out 6. If we're doing something like a matrix now, we have to enter in this slightly differently. So if I go x dot matrix, my x matrix is this 2x3 thing. So if I want to pull out, say, this one right here, or let's say, again, this one, this number 6 here, we have to specify first the rows, comma, the columns. So it would be x dot matrix, brackets, 3, comma, 2. And that should get, oh, that's not what I want. So we come back here, and if I go now, s dot matrix, 3, comma, 2, not 4, 2, it gives us back 6. So in a matrix, we can specify the row, comma, the column to get a specific element in there. And then similarly, we can do this in a data frame as well. This works also for a data frame. However, that being said, a data frame has, let's go back here, see if there's anything. Yeah, so again, row, column, or row, comma, column inside brackets for specifying things in 2-dimensional structures like matrices and data frames. However, that being said, data frames have a special way. Because they are a collection of vectors, we can call one specific vector at a time inside there. And we do this using the $sign thing. So we use the data frame name, $, the vector name inside there, or the column name inside there, and that will give us just that one column as if it's just a vector. So let's go back to here. We have our bio. Now this is a data frame, and bio is the data frame name. And like, let's imagine we want to just get age. It would be bio $age would just give us this vector 33, 44, 49, 68, 38, 70, all the way down of that one specific vector inside there. So let me clear this out real fast. If we go bio $, and then in RStudio, it'll actually, after you put in the $, usually bring up the different vectors that are inside there, or the different columns. So if you didn't want to actually enter it in, you could just go up and down, like, oh, I want age. Hit Control Enter, and it brings up all of the ages just as a vector, just in straight. So if then we want to pull out a specific one, there's 600 of them in here. Let's imagine I want the 534th element of there. I can then grab as 53. So I can call this as a vector inside the data frame, and then just ask for one specific element of that vector. Are there any questions to this point? Okay, let's talk very briefly about logical operators, and then we'll probably finish it up there. So we have these logical operators as well that we can use to kind of make logical tests to determine if some elements in a vector or something else in a matrix or something fall within a certain range or certain category. So for instance, 2 equals is, does this equal this? Greater than, less than, greater than or equal to, less than or equal to, all pretty intuitive. The only one that's a little bit weird is like equals actually means 2 equals. The reason for that is just a single equals is the assignment operator. Or then down here, does not equal, $, or excuse me, exclamation point equal is does not equal. So we can make now logical tests based on these logical operators. So for instance, I could go in there to Bio and look at the annual earnings and say, I just want you to then tell me which annual earnings are greater than or equal to 50,000. And it's going to give you a vector that matches up with the vector that you just interrogated, and each element, instead of being the number, is going to be true or false, whether or not this matches that logical operator. So let's go back to R here for a second. So imagine bio age. Let's use bio age, $age, and let's see which ones are greater than or equal to 50. Hit Control Enter. Let me pull this up. What it does is it gives you this vector for all 600 of those ages. So here again, here's the ages. And if we look here, the first 3 are not greater than or equal to 50. We have 33, 44, 48, and then 68. So it should be false, 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 true. Come down here to the logical vector, that's exactly what we get. We get false, 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 true. Okay, that might not seem like a lot at the moment, but, I mean, what are you going to do with this? One of the nice powerful things that we can do now is we can actually take this this as our subsetting. Like when we actually ask for specific elements of a vector now, we can use this logical operator to subset that. So for instance, I can put this inside, for instance, bio $, and then name, and then in parentheses go bio $age greater than or equal to 50. So now it's going to give me bio $name, and that's going to have this vector for every single one that says false, 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 true, false, false. For every false one, it will not give me that element back. For every true one, it will give me that element back now. So for instance, what I can do now is do this. So it's going to give me a vector of the names, but it will only give me the names of the people who are over 50. So in here, instead of having 600 different names, we only have 294. When you pull up a vector, this at the beginning of every is the element that we're at right here. So Edwin Rogers, the 241st element. If we go down here, 293 is Alice Matthews. This is then 294. So it only gave us about half of the names, and these are just the names of people that were over 50. Is there any questions with that? Okay, we're a little bit over. Lab this week is going to be in here. Eventually we are going to be down in the ecology classroom, but for this week we will meet in here and then go, or we probably won't go down there, but we'll just meet in here and have lab in here. That'll be tomorrow at 2 p.m. We're going to be going over more things that our introductions are. Again, this lecture is going to be posted up, and then also I'll take the PowerPoint and post it up as well into that same place, the lecture materials. If you have any questions, go ahead and stick around and ask me. Otherwise, you are free to scoot.
What's the comment symbol?
What's that?
What's the comment symbol?
Pound sign. Yes.
I have a field trip
Okay.
in April